In this lesson, we are going to be working our factoring problems backwards. So they're actually going to give us the roots or the solutions or the zeros to a problem, and they want us to write the quadratic equation. So looking at this first one here, they're telling us, when they say that the roots are half and negative 5, they're telling us x equals 1/2. X equals negative 5. So if I was to look at the graph of this parabola, you would see that the graph passes through the ordered pairs negative 5, 0 and 0.50. That's my roots. So this is the graph of this parabola. I now have to write the equation for this. So we're really going to be working backwards from what we did with factoring. Think of what our last step, when we factored, let's just look for a minute. What did we do when we factored, just to remind ourselves? If I have a problem like x squared plus 5x plus 6 equals 0, we would have factored this and said x plus 3, x plus 2, and then we set each factor equal to 0 and solve. In these problems, this is what they're giving us. So we're going to have to actually work backwards every step until we get to this as our answer. So for this problem, if they're saying x equals 1/2 and x equals negative 5, I want to go so I can say x equals 0. So here I would minus 1/2. X minus 1/2 equals 0. Add 5. X plus 5 equals 0. Now when we are factoring, we don't ever have fractions in this at this point, so like this is a little weird to see here. Normally how this would be written is 2x minus 1. So what we want to do here is just eliminate these fractions so they don't confuse us when we're foiling and we end up with a bunch of fractions we have to fix later. So I would have 2x, 2 times x, and then 2 times 1/2, so 2x minus 1. That's what that would have looked like for us when we factored. So now what we do is we take these two pieces right here that equal 0, and those would be our factors. So it'd be 2x minus 1 times x plus 5 equals 0. If you want to look back on this problem we did here, notice this went there, that went there. So same idea. Last step would be for me to actually FOIL these out. So I'm going to distribute the 2x to both terms. I would get 2x squared plus 10x. Distribute the negative 1 to both terms, so I have negative 1x minus 5, and then equals 0. And then I'll go ahead and combine like terms. So 2x squared plus 9x minus 5 equals 0. This is the quadratic equation with the given roots that they gave us, 1/2 and negative 5. To check this, what you could do is actually graph 2x squared plus 9x minus 5 on your calculator and make sure that you see that it crosses the axis at 1/2 and negative 5. That would tell you that you probably did that right. So we'll try another one. Number 5. I want you guys to try this one by yourself and then go ahead and unpause the video and see how you did. So for 5, hopefully right away you'd say x equals negative 1/3, x equals negative 2. So I'm going to add 1/3 to both sides so I get that equation equal to 0. X plus 1/3 equals 0. I'm going to add 2. X equals 2. Remember, we want to get rid of that fraction, so I'm going to times this by 3. So I have 3x plus 1 equals 0. So now here are my, oops, I wrote this one wrong, sorry. X plus 2, how about, equals 0. So here are my factors. 3x plus 1, x plus 2. I go ahead and FOIL these out. 3x squared plus 6x plus 1x plus 2 equals 0. So I have 3x squared plus 7x plus 2 equals 0. If you take a look at the graph, you could put that on your calculator, and you would get this picture, and you'd see that it crosses at negative 1/3 and 2. Last one then. If they tell me that it's a double root, what does that mean? Remember that means that you get the answer x equals negative 4 twice. That's what a double root means. So you just have to know that you would write that twice. When I add 4 to both sides, for both of these, I'd get x plus 4 equals 0. and then that's my two factors. So x plus 4 times x plus 4. We go ahead and distribute that x, and then distribute the 4. Combine like terms. So we end up with x squared plus 8x plus 16 equals 0 being our quadratic function. Take a look at the graph, and as I expected, my vertex would be happening right here at negative 4. Notice this is negative 5. Here's the 0. So at negative 4 is where my vertex is. Hopefully that makes sense to you. If you have any questions on that, you can let me know tomorrow.